All right, let's do the problems for chapters 16 to 18. We only have 6 problems because on this test, most of the questions will be conceptual. All right, so number 32, we've got the same amount of water, so it's the same mass. And the setup becomes simple. We know that the cold amount will go up in temperature, the hot amount will go down. Since the masses are equal, we can just set it up like 15 degrees plus delta T equals 95 degrees minus delta T. Doing the algebra on that, we get 55 degrees Celsius as our final temperature. All right, number 33. They basically tell us right away that we're dealing with 510 watts. And so for A, 510 joules per second is just another way to write that. In B, Q equals mc delta T. We know that 1 liter is 1 kilogram, so we can plug in 0.5 for the mass. Also 4186, specific heat of water. And they want to know how much energy it will take to raise it 1 degree, and that's why we put 1 in there. It's 2.1 kilojoules. In C, we divide that energy by the power, so joules divided by joules per second. The joules cancel and we end up with 4.1 seconds. Now that's for 1 degree. In D, they're asking about 80 degrees. So we just multiply that time by 80 and we come up with 328 seconds or 5.5 minutes. In 35, we want to raise the temperature of the system. So the system is the water plus the copper. And they have very different specific heats. So we need to take both of those into account. In B, we're looking at the water. And so 1.90 times 4, 186 times 80. And we get 636 kilojoules. And in C, we do the same for the copper. And we find that it's 57 kilojoules. Now, in D, all we're doing is we're adding up those required energies, those required heats, to find that we need a total of 693 kilojoules. And then we just convert that to kilocalories. So the final answer is 1.7 times 10 squared kilocalories. Okay, number 37. 1 kilocalorie is equal to 4186 joules. And a really handy thing to do in these setups is to label cold and hot. The reason it's helpful is because it kind of just makes sure we don't get confused about what we're plugging in. So M cold, C cold, delta T equals negative M hot, C hot, delta T. What the negative is doing there is, think of it this way, a hot thing loses heat, so you're subtracting from it, whereas the cold thing gains heat, so that's positive. Okay, so now we do our plugging and chugging with our givens, and we find that the mass of the cold that we were looking for is 0.11 kilograms. The next two problems are similar. Same setup, M cold, C cold, delta T equals negative M hot, C hot, delta T. And again, we just do our plugging and chugging. Notice that delta is always final minus initial. And that's why we do the TF minus in both on both sides of the equation. So then we're solving for TF and we find that it's 89 degrees Celsius. And finally, number 40. Same setup, same plugging and chugging, and the TF is 79.7 degrees Celsius. All right, that's it for the short problem set. In the review game, we will talk about your concept questions. And you can really get the answers for those from your notes, so make sure you study your notes. See you in class.